Hi, I am Rashani DeBell, and you are learning algebra. Hi everybody. In today's lesson, we are going to learn how to graph a quadratic inequality. Let us start by looking at what a quadratic inequality is and the steps to graphing a quadratic inequality. Graphing quadratic inequalities. Our objective is to sketch the graph of a quadratic inequality. Here are some key terms that we need to know. Quadratic inequalities can be written as follows. Y is less than ax squared plus bx plus c. Y is less than or equal to ax squared plus bx plus c. Y is greater than ax squared plus bx plus c. And y is greater than or equal to ax squared plus bx plus c. Notice that in all of these inequalities, they are written in standard form where I have a positive y and I have ax squared plus bx plus c. This allows me to easily identify what my a term is, my b term is, and c term is so that I can find the vertex, the roots, use an input-output table to graph these quadratic functions. The graph of a quadratic inequality is the graph of all ordered pairs x and y that are solutions of the inequality. In a graph of a quadratic inequality, we have multiple solutions to the inequality. It is always in the shaded region of the inequality, and there's always going to be numerous solutions to this inequality. Here are the steps to sketching the graph of a quadratic inequality. Step 1. Ignore the inequality and sketch the graph using the equation y equals ax squared plus bx plus c. What this means is use this function here to find your vertex, your roots, and to create an input-output function table. Once you find that, for less than or greater than, sketch a dashed parabola. A dashed parabola just means that the solutions to the inequality are not on the parabola. For a less than or equal to or a greater than or equal to, sketch a solid parabola. A solid parabola means that the solutions to the inequality are on the parabola as well. Shade the solution area. If your inequality is less than or equal to, shade below the function. If your inequality is greater than or equal to, shade above the function. Test your solution by picking a point in the shaded region and plugging it into the original inequality. If it makes the inequality a true statement, then you've got the correct shaded region and the correct solution to the inequality. Now let us look at an example of graphing a quadratic inequality. We are asked to sketch the graph of y is less than x squared minus 4x. I am going to start by identifying what my a, b, and c terms are. A is always the number by our square term, which in this case is x squared, and since I don't have a number over here, I know that that's an invisible 1. B is by the variable that's by itself. In this case it's x, and the number by x is -4, so it's -4. And c is our constant, which we don't see a constant over here or a number by itself, so here c is 0. Once I've identified my a, b, and c, I'm going to now do the steps to graph the quadratic function. My first step to graphing a quadratic function is to use the formula to find the x vertex, and the formula is x is equal to -b divided by 2a. So to find my x vertex, I'm going to have negative times a -4 divided by 2 times 1. Negative times a negative is a positive, and that gives me a +4. 2 times 1 is 2, and 4 divided by 2 is 2. Remember, my x vertex is also my line of symmetry, or gives me my axis of symmetry. So at x equals 2 is where my parabola can fold in half and be symmetrical. I also have here my x vertex at x equals 2. Now that I have my x vertex, I'm going to use that to find my y vertex, and to do that I'm going to plug it into my original function, and I'm going to plug 2 into my original function. So I have 2 square minus 4 times 2. 2 square I know is 4. Negative 4 times 2 is negative 8. And 4 minus 8 gives me negative 4. So my y coordinate of my vertex is negative 4. I'm now going to find my roots for my function. And to find my roots, I'm going to use the formula, or the quadratic formula, negative b plus or minus square root of b squared minus 4ac, all divided by 2 times a, where I know that my b is negative 4, so it's negative times a negative 4, plus or minus square root of negative 4 square minus 4 times 1 times 0, all divided by 2 times 1. Let's go ahead and simplify. Negative times a negative is a positive, so I get positive 4 plus or minus negative 4 squared is just 16. Negative 4 times 1 is negative 4 times a 0 is just 0, all divided by 2 times 1, which is 2. Can simplify that. 16 plus 0 is 16, and then the square root of 16 is just 4. Since my discriminant over here is positive, I know that I am going to have 2 distinct solutions to this quadratic function, and I can find these solutions by finding x equals 4 plus 4 divided by 2, which gives me 8 divided by 2, which gives me 4. So one of my solutions is at x equals 4. The other one can be found at x equals 4 minus 4 divided by 2, which is 0, divided by 2, which gives me 0. So there are my 2 roots, x equals 0. In order to get a decent looking parabola, I am going to create an input-output table to get some coordinate points that I can plot in addition to my roots to create this nice looking parabola. So I'm going to choose some values for x, plug it into my quadratic function x squared minus 4x to create some values for y. I'm going to choose the value of x equals 3, and I'm going to get 3 squared minus 4 times 3, which 3 squared is 9. Negative 4 times 3 is 12, and 9 minus 12 gives me negative 3. So at x equals 3, I'm going to have the value of y equals negative 3. I'm also going to choose 5, and then I'm just choosing points over here. So I've got 5 squared minus 4 times 5, which 5 squared is 25. Negative 4 times 5 is negative 20. 25 minus 20 gives me 5. So at x equals 5, I got y equals 5. Now that I have my axis of symmetry, my vertex, my roots, and some coordinate points, I am now going to go to plot, connect, reflect, and shade. Let us start by drawing our axis of symmetry, which we know is at x equals 2. We'll also plot our vertex at x equals 2, y equals negative 4. And we'll plot all of our other points. We've got our roots at x equals 4 and at 0. And you know that your roots are correct because you can see that it is symmetrical, that this x equals 0 is 2 points away from the axis of symmetry, and x equals 4 is also 2 points away from your axis of symmetry. We also got at x equals 3, y equals negative 3, and I'm going to reflect that. This is 1 across from the axis of symmetry, so reflection would be 1 across from the axis of symmetry. I also have at x equals 5, y equals 5. This is 3 away from our axis of symmetry. So 3 away from our axis of symmetry with reflection. 1, 2, 3. It's right over here. And now I'm going to connect my points on my parabola. And now here's where the inequality comes in. I'm going to look at my inequality. I'm going to say, okay, this is a less than. Because it's a less than, and it's not a less than or equal to, my parabola has to be a dashed parabola. Here's my parabola for the function y is less than x squared minus 4x. My last part in this step is to shade. Since this inequality is a less than inequality, I'm going to shade below my function to show that it is less than. This area is below my function y is less than x squared minus 4x. Last step is to check. In order to check if this shading is correct, I'm going to just choose a point in the shaded region. And I prefer to use, whenever possible, 0 values and positive values. So I'm going to use this point over here. X is equal to 7 and y is equal to 0. You can choose any value that you like to check if your inequality is correct. Choosing the value x is 7, y is 0. Going to plug this in to my original inequality over here and see if it makes it a true statement. So I've got is 0 less than 7 squared minus 4 times 7. So we know that 7 squared is 49, and negative 4 times 7 is negative 28. 49 minus 28 is 21. Is 0 less than 21? Yes, it is. And so this region over here where my solution is in the shaded region, and therefore this is the correct solution to the inequality y is less than x squared minus 4x. And that concludes our lesson on graphing quadratic inequalities. Thanks for watching.